Good morning everyone. In our last lecture, we have discussed how to derive the regression equation using normal equations. We learned how least square method is applied to estimate the regression line by minimizing the sum of squared residuals, and we derived the expression for regression coefficient based on those normal equations. See, today we are going to move one step further and discuss the regression equation through deviation, which is taken from arithmetic mean. And in this particular approach, instead of directly approaching with the actual value of x and y, we simply going to calculate by taking the deviation taken from the x and y from their respective mean. Moreover, see, the normal equation method is very tedious because we need to solve the simultaneous equation, especially for getting the value of alpha and beta using a large sums. So instead of dealing with such an actual value of variable x and y, we are going to take the deviation of x and y series from their respective mean. So here the deviation taken from the mean, see, we know the arithmetic mean of the x. Let us consider two variable x and y. See, the arithmetic mean of x, which is equal to x bar, which is the sum of x divided by n. Similarly, the arithmetic mean of y, which is equal to y bar, which is sum of y divided by n. We know that is how to calculate the arithmetic mean of a particular variable. Then the deviation which are generally taken from its mean, that is small letter x, which is denoted as, that is x minus x bar. From the actual value, we are going to minus or subtract the mean value. Similarly, the small letter y, which we are denoting that y minus y bar. Okay. Now, by using this arithmetic mean value, we are going to calculate, the regression coefficient. See, regression equation based upon the deviation taken from mean. See, since we are already discussed, we have a two regression line, that is, one is the regression equation y on x and regression equation x on y. See, in the case of a regression equation y on x, see, which is generally calculated by using the equation or formula, that is y minus y bar, which is equal to r into regression coefficient, correlation coefficient into then standard deviation of y divided by standard deviation of x into x minus x bar. So this is the this is the generalized formula for framing the regression equation, that is especially regression equation y on x. So here, see, the r into the standard deviation of y divided by the standard deviation of x. This is nothing but this is the regression coefficient of y on x, which is generally denoted by using byx. So by using this one, see, we can also write that is y minus y bar, which is equal to byx into x minus x bar. Similarly, we have the second regression equation, that is regression equation x on y. See, it is generally framed by using the formula, that is x minus x bar, which is equal to correlation coefficient into the standard deviation of x divided by standard deviation of y. Earlier, in the case of an regression equation y on x, we used that is standard deviation of y divided by standard deviation of x, but here we are going to use that is standard deviation of x divided by standard deviation of y into y minus y bar. And here also, the r into standard deviation of x divided by standard deviation of y, which is nothing but this is generally representing for the regression coefficient y on x, x on y, which is generally denoted by bxy. Okay, so we have a two regression equation. By using this formula, we are going to calculate or going to frame the regression equations. Now, see, the byx, that is regression equation y on x, we already said that the coefficient which is equal to, that is the correlation coefficient into standard deviation of y divided by standard deviation of x, and bxy, which is denoting that it is r into standard deviation of x divided by standard deviation of y. This is the regression coefficient for the x on y. Now, if you go for multiplying byx into bxy, see, byx and bxy, which is equal to r into standard deviation of x divided by standard deviation of y into r into standard deviation of y divided by standard deviation of x. So the standard deviation of x and x will be cancelled out and standard deviation of y and y will be cancelled out. What is remaining here? It is r into r, which is equal to r square. So this is showing that the product of two regression coefficient is always equal to the square of correlation coefficient, that is r square, which is also known as it is coefficient of determination. So from, if you able to estimate the r square by using the regression coefficient, you can also calculate the correlation coefficient, that is r, which is equal to under root of the both regression coefficient, that is bxy into byx. So the correlation coefficient is the geometric mean of the regression coefficients. So here, see the regression coefficient, that is here we are denoting the byx. This is the regression coefficient of byx. That's why it is correlation into standard deviation of y divided by standard deviation of x, which is equal to the sum of xy divided by sum of x square. We are going to prove it how we are reaching into this particular formula. So we are going to discuss the derivation as well. Similarly, here we are denoting the bxy. So here it is r into standard deviation of x divided by standard deviation of y, which is equal to the sum of xy divided by sum of y square. So here only denominator is changing. One is sum of x square and another one is sum of y square. Okay. Now we are going to prove the coefficient, regression coefficient, that is r into standard deviation of y divided by standard deviation of x, which is equal to sum of xy divided by sum of x square. See, this is generally denoting, that is, value of beta hat. So this is the, we are going to prove here through the derivation. See, we know that x is equal to x minus x bar and y is equal to y minus y bar. We are going to consider here the population regression model, that is y is equal to alpha hat plus beta hat x plus e. Alpha is the intercept, beta is the slope, x is the independent variable, y is the dependent variable, and e is the error term or residual. Okay. Now what we are going to do, we are denoting, this is equation number 1. See, we are going to add the sign in the both side. See here, the sum we are going to add in the both sides. See, it will become sum of y, which is equal to, see, alpha hat, here it is a constant. So sum of alpha hat, which will become n into alpha hat, plus beta hat is the constant. So we are taking the first beta hat into sum of x plus the sum of e, sum of residual here. Now we are going to divide, all the terms here by using n. So it will become, see, sum of y divided by n, which is equal to n into alpha hat divided by n plus beta hat into sum of x divided by n plus sum of e divided by sum of residual divided by n also. See, what do you mean by sum of y divided by n? This is nothing but it is the y bar, it is the mean value. So you are denoting this, it is mean value, that is y bar, which is equal to alpha hat, n will be cancelled out. So it will be alpha hat plus, see, beta is here, sum of x divided by n, which is nothing but it is the x bar, that is mean value of x. And if you go for summing up the error term, then it will become 0. Okay. So the second equation I am denoting here, it is y bar is equal to alpha hat plus beta hat x bar. Now we are going to consider the both equation together, the equation number 1 and the equation number 2. Now see, we are going to subtract the equation number 2 from the equation number 1. See, we will get, see, y minus y bar. So y minus y bar, then alpha hat minus alpha hat will be cancelled out. Then what is remaining here, which is equal to beta hat x minus beta hat x bar. So beta hat is common, so I am going to take into the outside. So beta hat into x minus x bar plus what is remaining here, it is e. E is remaining here. Okay. Now we know what is the y minus y bar. Y minus y bar we can denote by using the small letter y. Similarly, it is what is remaining here, it is beta hat x minus x bar, we can say that it is the small letter x also. What is remaining here, it is e. I am denoting, this is equation number 3. So this is y is equal to beta hat x plus e. Okay. Now I am going to rewrite the equation number 3, see, in terms isolating for e. This I am going to isolate the equation number 3 for e. Then it will become y minus beta hat x, y minus beta hat x. Now this is the residual for the each observation. We will have an each error term, that is for the each observation we will have a residual. If we simply sum this particular all the residual, that is sum of ei, see what happened, they might be cancelled out because there are some positive values and there are certain negative values also. And if you go for summing up, it will giving you a 0 value, which tell us, nothing about how large our error term are. See, we are going to use a least square method here, which minimize the sum of squared residual, that is error term, because it minimizes sum of squared residual. The total distance, that means the squared between the observed point and the regression line. So that's why it is called the method of least square, and in this particular case we are going to use the method of least square method especially for finding out the alpha hat and beta hat, that is the intercept term as well as the slope term, to make the total squared error as smaller as possible. Okay, so that we are going to square it here. The sum of e square, which is equal to, see, sum of y minus beta hat x whole square. Okay, now I am going to minimize. In order to minimize sum of e square, we are going to differentiate this particular term with respect to beta hat. See, by using the generalized power rule, we can apply here the generalized power rule of differentiation, and I am going to differentiate this particular function with respect to beta hat. So it will become, see, it is the partial derivation of the sum of e square with respect to beta hat, which is equal to, see, n into, that is 2 into sum of the given function f of x, that is y minus beta hat x whole square, see, it is in power, it will be n minus 1, so it will be 2 minus 1 into what is the derivative of the beta hat x, so it will become beta hat, the coefficient will become minus 1, so it will be minus x. Okay, now I am going to multiply minus x with 2, so it will be, see, we can write it, it is minus sum of x, it will be minus 2 sum of x, then what is in bracket, it will be y minus beta hat x, then 2 minus 1, the square will become 1. Okay, now see, minus 2 sum of, we can open this particular bracket, so it will become minus 2 sum of xy, minus minus will become plus, so plus 2 beta hat sum of x into x, which will become sum of x square. Now I am going to equate with the 0 and also dividing with the 2. See, it will become, if you go for dividing the both the term by 2, it will become minus sum of xy, then plus 2 and 2 will be cancelled out, beta hat sum of x square. Equating with 0, and we can write it, it is beta hat sum of x square is equal to, taking this term into the right side, so it will become minus sum of xy will become plus sum of xy. And if you go for isolating for beta hat, then it will become sum of xy divided by sum of x square. It will goes to the denominator side. So hence we are actually proved the value of beta hat, that is the regression coefficient, and the slope value, that is sum of xy divided by sum of x square. So this is the beta hat, and this sum of xy, what is this x, which is the x minus x bar, and what is y, it is y minus y bar, and in the denominator sum of x square we can write it is sum of x minus x bar whole square. So in this way also you can rewrite this particular value of beta hat. Now after finding the beta hat, we also want to find out the value of alpha hat also. For that we are going to consider our second equation. See, what was the second equation? It was y bar, which is equal to alpha hat plus beta hat x bar. This is this equation number 2. And if you go for isolating alpha hat, then it will become y bar minus, taking this into the left side, so it will goes to the minus beta hat x bar. So this is the value of the alpha hat also. Now, in the earlier lecture, we are derived the regression equation by using the normal equation. See, at that particular point of time, the value of beta hat, which we are used, that is n into sum of x y, which minus sum of x into sum of y whole divided by n into sum of x square minus then sum of x whole square. See, this is the value of beta hat, which we are actually calculated by using the actual value of x and y. This value is also equal to the what we are actually derived in the earlier slide, that is sum of xy divided by sum of x square, which we are going to prove. That is how sum of xy divided by sum of x square will equal to the the formula which is actually used for calculating beta hat, while which we are actually derived by using the normal equations. So that we are going to prove it here. What is the value of beta hat, which is equal to sum of xy divided by sum of x square, which we are already derived earlier. which is equal to the value of x is equal to x minus x bar into y minus y bar whole divided by sum of x minus x bar square. Now here, see, we are going to derive, first we are going to consider the numerator term, that is sum of x y. See, sum of x y which is equal to sum of x into x bar y into y bar. Okay. Now I am going to open this particular bracket by multiplying the each term, so it will become x into y which is xy minus x into y minus y bar which is equal to minus xy bar. Then again minus x into y which is equal to minus x bar into y plus minus will become plus, so it is x bar y bar. Okay. Now I am going to open the bracket here by adding the multiplying with the sum, so it will become sum of xy minus y bar is the constant, so I am taking to the outside y bar sum of x. Then here x bar is the constant, so x bar into sum of y plus n into x bar and y bar. See, sum of x bar and y bar, since x bar and y bar is the constant, we can say that it is the n into x bar y bar. Now see, sum of xy I have written as it is. See, what is y bar? Y bar is the mean, so it is the sum of y divided by n. What is remaining here? It is sum of x minus x bar, here it is the mean value of x, so we can write it is sum of x divided by n into sum of y plus then n into x bar. Instead of x bar I am writing it is sum of x divided by n, sum of y divided by n for the y. Now we can rewrite here, see, it is sum of xy. I am going to multiply these two numerator terms, so it is sum of y into sum of x divided by n minus sum of x sum of y divided by n plus, see here, sum of x into sum of y, n into n, which will become n square. So n is here. Then after that, sum of xy minus, see, this term is as it is, this term also as it is written. This n and n will be cancelled out, one n will be cancelled out, so it will become sum of x minus x into sum of y divided by n, because one n will be cancelled out here. Now see, these are the two equal words, so minus sum of xy divided by n plus sum of xy divided by n will be cancelled out. What is remaining here? It is sum of xy minus sum of y into sum of x divided by n. So these two terms will be remaining here. Now I am going to rewrite this is by taking the common denominator, that is n, by multiplying the first term by using n. So it will become sum of xy is equal to, that is numerator term will equal to n into sum of xy minus sum of y into sum of x divided by n. Okay. Now see, consider the denominator side. See, since we are already calculated, that is the value for the numerator, now we are going to consider the value for the denominator, that is sum of x square. See, sum of x square means it is sum of, what is x? It is x minus x bar whole square. See, this is a minus b whole square term. So it is equivalent that. So a minus b whole square is equal to a square plus 2b square minus 2ab. So it will become, we can rewrite, it is sum of, see, it will become x square plus x bar square minus 2ab, that is 2 into x bar. Now I am going to open this particular bracket. See, it will become sum of x square plus sum of, see, x bar is the constant, so sum of x bar will become n into x bar square minus, see here x bar is again constant, so I am taking to the here first, so it will be 2 into x bar, then what is remaining here? X, so sum of x. Now see, the sum of x square I am putting as it is, so here n into x bar, what is x bar? It is the mean value, so it is sum of x divided by n whole square minus 2 into, this is again x bar here, it is the sum of x divided by n and sum of x also here. Okay, now sum of x square plus, see, n into this term I am writing as it is minus 2 into sum of x will become sum of x whole square divided by n. Now again I am going to rewrite, this is sum of x square plus, see, n into, see, this is square, so I am writing separately, so sum of x divided by n, sum of x divided by n minus 2 into sum of x whole square divided by n. Now again here, if you go for multiplying these two terms, so sum of x and sum of x I have written here in the numerator, and the denominator n into n will become n square, and all other terms are remain the same. So it will become, see, sum of x square plus, see, this I can write, this n will be cancelled out, this one n and here n will be cancelled out, so it will become sum of x divided by, sum of x into x, sum of x divided by n minus 2 into sum of x whole square divided by n. So again we can summarize, simplify it, that is sum of x square plus, see, what is this? Sum of x into sum of x will become sum of x whole square divided by n minus 2 into sum of x whole square divided by n. See here, both terms are same, one is plus and another one is minus, so plus and minus will be cancelled out, so only one sum of x square divided by n will be remaining here. This will be cancelled out. So sum of x square, that is denominator sum of x square, is equal to sum of x square minus sum of x whole square divided by n. Now we are going to multiply the both side of the equation by using the n. Then it will become n into sum of x square is equal to, then n into, again I am going to multiply with the n. So n into sum of x square minus n into sum of x whole square divided by n. See, again here n and n will be cancelled out. See, so it will become n into sum of x square is equal to n into sum of x square minus sum of x. This n and n will be cancelled out. Now I am going to take this n into the right side, so it will goes to the denominator side. So sum of x square is equal to n into sum of x square minus sum of x whole square divided by n. Okay, so this is the denominator value, that is sum of x square is equal to n into sum of x square minus sum of x whole square divided by n. Now I am going to consider the numerator and denominator which we are already written here. See, sum of xy, which is already derived here, and sum of x square also derived. Now I am going to consider both the numerator and denominator together, so it will become beta hat. Instead of sum of xy, I am going to write this value, and instead of sum of x square, I am going to write this one. So it will become like this. See, by using reciprocal rule of division, see, we can write this one, the numerator term as it is I have written, then the denominator term will become, see, numerator will become in the denominator will become in the numerator, and numerator will become in the denominator side. So we can write, see, in this particular format as per the rule of reciprocal rule of division. Here n and n will be cancelled out. So what is remaining here in the numerator, it will be n into sum of xy minus sum of y into sum of x, then whole divided by n into sum of x square minus sum of x whole square. So this is what actually we are derived in the normal equation case in the last lecture. So it is also equal to the sum of xy divided by sum of x square. Okay, so hence we are proved that the beta value by using the normal equation and beta value by using the deviation taken from its mean, both are the same. Okay. Now we are going to consider some numerical examples here. We want to calculate regression line by using the following data. So x and y values are given here. See, I have considered here x, and the sum of x is equal to, it is 45, and the x bar here is nothing but it is sum of x divided by n. So it is 45 divided by 9. Since we have a 9 observation, so it will become 45 divided by 9, which is equal to 5. Now I am going to calculate small letter x, that is x minus x bar. So 1 minus 5, which is equal to minus 4, 2 minus 5, which is equal to minus 3, and accordingly I have taken the difference between x minus x bar. And then I have squared it, so x square, which will become minus 4 square, which is 16, and minus 3 square, which is 9, and so on, and the sum of x square is equal to, I have added all these values, which is equal to 60. Similarly, we have a y values also which is given, and the sum of y is equal to 108, and I have calculated the mean value of y, which is sum of y divided by n, that is 108 divided by 9, which is equal to 12. Now I am going to calculate the small letter y, that is the difference between the actual value of y with y bar. Okay, that is mean value of y. So it will be 9 minus 12, which is equal to minus 3, 8 minus 12, which is equal to minus 4, and so on. And then I have squared the each values here. So y square, minus 3 square, which is 9, minus 4 square, which is 16, minus 2 square, which is 4, 0 square 0, and accordingly I have added all these observations together, so it will become sum of y square, which is equal to 60. Then I have added one more column, that is by multiplying small letter x and small letter y. So it is minus 4 into minus 3, which will become 12, minus 3 into minus 4, again it will become 12, and so on. And accordingly I have added together all the values here. So sum of xy, which is equal to 57. Now after calculating all these things, I have written here all the values separately so that it will be very easy for calculation. So the the coefficient of regression, that is y on x, that is byx, which we are already said that the coefficient can be calculated by using this particular formula, that is sum of xy divided by sum of x square. So I have calculated here the sum of xy, which is equal to 57, and divided by sum of x square, which is equal to 60. So 57 divided by 60, which is equal to 0.95. And regression coefficient, it is y on x, which we can formalize it by using this particular formula, that is y minus y bar, which is equal to regression coefficient, then x minus x bar. So it will become y minus, what is y bar? y bar it is 12, so I have written here it is 12 into, this is the regression coefficient which we are already calculated here, it is 0.95 into x minus x bar. What is x bar? Which is equal to 5. So this is the x minus 5. Then you can simplify it, see by opening this particular bracket, so it will become 0.95x minus, if you multiply these two terms, it will become minus 4.75. Then I am going to take minus 12, or I am going to add the plus 12 into both sides of the equation, so it will become, see, y is equal to 0.95x minus 4.75 plus 12, which will become, y is equal to 0.95x plus 7.25. So this is the regression equation y on x. See, similar way we can also calculate the regression equation x on y. Here also we can calculate the regression coefficient, that is bxy, by using the formula, that is sum of xy divided by sum of y square. Instead of sum of x square, here it will become sum of y square. So here it will be, see, sum of xy which is equal to 57 divided by what is sum of y square, which is equal to 60. So 57 divided by 60, which is again come out with 0.95. So we can formulate, that is here x minus x bar, which is equal to 5, which is equal to 0.95, that is regression coefficient. Then y minus y bar, which is equal to 12. So if you go for simplify it, then it will become, see, x is equal to 0.95y minus 6.4. Now one more example I am going to consider here. See, here the data on the salesman's test score and the sales is given here, and we also want to see calculate the regression coefficient of sales on the test score, and we also want to estimate the probable weekly sales of volume if A is sales make test score of 100. Okay, so here what we want to calculate, here we want to calculate the y on x, since we are saying that it is the equation, regression equation of sales. So it will be y is the y on x which we want to calculate here. So x I have written here, and the sum of x is equal to 600. I have calculated the x bar, which is equal to 600 divided by n, that is number of observation, which is 10, which is 60. Then I am going to take the deviation from actual value, so it will be x. So it will become, see, 40 minus 60, which is minus 20, and accordingly the remaining values I have calculated here and then squared it. So minus 20 square, which is 400, and accordingly the each value I have calculated here and summed it together, so it will become sum of x square, which is equal to 2400. Similarly, we have y value, and the sum of y is equal to 40, and the mean value, which is equal to 40 divided by 10, which is equal to 4. So accordingly I have calculated the small letter y, which is y minus 4. So 2 minus 5 minus 4, which is equal to minus 1.5, and so on the remaining values. And then after that I have squared the each values here, so it will become y square, and after that I have added together all the y square values, so it is sum of y square, which is equal to 14. Then I have also calculated the x and y, so x and y, so it is minus 20 into minus 1.5, which will become 30. 10 into 2, which will become 20, and accordingly the remaining values also calculated, and the sum of xy is equal to 130. Okay, now by using this information we can calculate the regression equation y on x. See, the sum of xy which we are already calculated, which is 130, divided by sum of x square, which is 2400, and if you take the ratio of these two terms, so it will become 0.054. Okay, this is the regression coefficient, and then we can calculate the regression value also, that is y minus regression equation also, that is y minus y bar, which is equal to r into, that is regression coefficient, r into standard deviation of y divided by standard deviation of x into x minus x bar. See, what is y bar, which is equal to 4. So instead of y bar I have written here y minus 4 equal to regression coefficient, which we are already calculated here, it is 0.054. Then into x minus, what is x bar, which we are already calculated, which is 60, so x minus 60. If you go for simplify it, then it will become, open the bracket, so it will become y minus 4, which is equal to 0.054 into x minus, if you multiply these two terms, so it will become 3.24. Then simplify it by isolating for y, then y will become 0.054x plus 0.76. So this is the intercept term, and this is the slope term, and this is the independent variable, and y is the dependent variable. Now by using this information, see, our question is that what is the value of y if x is equal to 100? So we are going to calculate here by substituting the value of x is equal to 100. So it will become, see, this is the regression equation, that is y is equal to 0.054 x plus 0.76. So it will become, see, y is equal to 0.054. Instead of x, I am substituting here, it is 100 plus 0.76. So if you multiply these two terms, so it will become 5.4. Then if you add together, it will become 6.16. So we can interpret this particular term, that is the probable weekly sale volume of the salesman. If the test score, if he achieve the 100, that is equal to 6.16. So I am going to conclude here. In this particular lecture, we have actually discussed the how to calculate the regression equation by using the deviation taken from its means. In the next video, we are going to discuss by using how we are going to calculate the regression equation by using assumed mean. So we are going to conclude here. Thank you.